So let's look at this, again, executing a program, then byte by byte. Assuming that the program is burned into the ROM of a PIC-18 chip, the following then is a step-by-step description of the action of the PIC upon applying power to it. First, when the PIC is powered up, the program counter has 00000 and starts to fetch the first opcode from location 00000 of the program ROM. In the case of the program, the first opcode 0E, which is the code for moving an operand to the working register. Upon executing the opcode, the CPU places the value 25 in the working register. Now, one instruction is finished. Then the program counter is incremented to point to 00002, program counter 00002, which contains opcode 0F. The opcode for the instruction add LW34. Okay, so we can see that in those first two steps. Upon executing opcode 0F, the value 34 hex is added to the working register. Then the program counter is incremented to 0004. ROM location 0004 has the opcode for instruction add LW11 hex. This instruction is executed, and now the program counter is at 0006. This process goes on until all the instructions up to move WF sum are fetched and executed. Notice that all the above instructions are 2-byte instructions. That is, each one takes 2 memory locations. Now, PC, the program counter, is at 00E. It points to the next instruction, which is go to here. This is the 4-byte instruction. It takes ROM addresses 0E, 0F, 10, and 11. After the execution of the instruction, the program counter then equals 0000E. This keeps the program in an infinite loop. If your PIC trainer has a monitor program, you do not have to use the goto instruction, and the program will go back to the monitor program. The fact that the program counter points to the next instruction to be executed explains why some microprocessors, notably the x86, call the program counter the instruction pointer.